Hello class, welcome to lesson 2. Hope you guys are having a good week so far. I see most of you, or many of you have watched videos already for lesson 1, and you are also handing in homework, so thank you very much. I just want to let you know that handing in your homework is attendance for the week, so we are required to mark attendance by marking that you have participated in class. And I always say, hey, handing in homework is participating. So once you hand in a homework assignment, I will mark you as present for the week. And I will do that weekly. As long as you hand in any homework assignment, I will mark you as attending. And that will be your attendance for the week. I hope you hand in all your homework assignments because the homework is part of your grade. Just quickly to let you know, just to reference back in the addendum, I did change the amount of what each section of the course counts for because I am not going to have a final in the class. I'll just have 2 more exams and a few quizzes and, of course, homework. So I'm doing away with the final exam. It just did not fit into the schedule anymore, and I will just have 2 more exams. So I updated. Please look at the addendum. You'll see what the schedule is. And as I open each module for each week and each lesson for each module, you'll see what we're going over and what homework needs to be done. All right? So thank you very much for doing that. I just wanted to point out real quick here, I am on page 348 if you have your books. But before we go into section 4, here we have Albert Einstein, and one of the things he used to say was that compounding interest was the 8th wonder of the world. And there's a special rule that you can use, and it's kind of interesting. I wanted to point it out that if you're trying to figure out how long it would take to double your money using compounding interest, you would need to just quickly use the rule of 72. And basically, it's taking 72 and dividing it by the compound interest rate, and that would give you how many years it would take to double your money. So, for example, if you invested 6% compounding interest, or invested your money at 6%, it would take 12 years. 72 divided by 6 equals 12. If you invested your money at 9%, 72 divided by 9 is 8, so it would take 8 years to double your money. All right, so that's kind of interesting. If you could get something that earned 36% in a year, then 72 divided by 36 would mean you double your money in 2 years. That's kind of cool. But let me know where you can find 36%, and we'll all invest in it. All right. So anyway, I just wanted to point that out. All right. Just to briefly recap, we have so far talked about compounding interest and then calculating it using the simple interest per compounding period. We quickly found out that that's a bear to use, so we don't do that anymore. Or we don't want to do that anymore. You know how to do it, but we were using the tables, and in the tables, as long as you could calculate the interest per compounding period and how many compounding periods there are, you could look up at the table for the factor that you would multiply the principal by, and that would tell you the compounding amount at the end of those compounding periods. And then you could find the interest by subtracting the principal from the compounding amount. So that was just a quick review. We also found out how to expand the table if there aren't enough compounding periods in the table. You could just take the number of compounding periods, divide it by 2 in what you're trying to figure out, or as close to half as possible, and then find those compounding periods. So if you had 30, you would look up 15, all right, in the table. And if I quickly look at that, so in the compounding, so if you were looking for 30, you see it only goes to 25, so we would look up 15, find the interest rate, and then we would take that interest rate, and since it takes 2 periods, 15 plus 15 equals 30, we would multiply those rates by each other to give us the new compounding rate. And once we found that, then we could easily go about figuring the new compounding amount. All right, so now let's move on to section 4 here. And what we're wanting you to do is figure out what is the annual percentage yield. All right. So what we've been talking about is the nominal interest rate. The interest rate we use to figure out what we are compounding, how to find the interest on for a compounding interest. We call that the nominal rate. But we quickly found out that when you compound, the more compounding periods you have, the more interest you earn. So as you can see in the table here, suppose we have $100 at 12% nominal interest. That's the interest we're going to use to figure out the compounding interest. So annually, we would just compound once in 1 year, and that would give us $12. 12% times 100 is 12. Semi-annually, we have to compound it twice. That would end up giving us $12.36 when we calculate it out. Quarterly, 4 times a year, $12.55. All right, and monthly, 12 times a year. That would give us $12.68. Now, recognize that if we do it annually, that would give us 12% interest at the end of the year. If we do it semi-annually, we're actually going to have 12.36% interest. The interest rate keeps going up. Quarterly, 12.55%, and monthly, actually more than 12.5%, 12.68%. So you see, the more compounding periods in a year, the higher interest we get. And we call that actual rate of interest the annual percentage yield. That gives you an actually truer account of how much interest you're going to earn for that year. They don't use it to calculate the interest, that's the nominal rate, but that gives you the percentage of what you actually earn. So we call that the annual percentage yield. And if you look at advertisements for savings accounts and things of that nature, you will see they will advertise the APY. Or if loans, you're getting a loan, here's the APY of the loan, but here's the nominal rate we use to actually calculate the interest. So that's how they work that. So in order to find APY, all you do is take the total compounding interest earned in 1 year and then divide that by the principal. And just like we did in the example, as we were looking over here, that is how you find the APY. And it will be different than the nominal rate. So here in example 4, we'll go over that real quick. What is the compounding amount, compound interest, and annual percentage yield of $4,000 invested for 1 year at 8%? Compounded semi-annually, so that's twice a year. So the interest rate for the compounding period is going to be 4%. 2 periods in a year. Divide that into 8%, so that's 4% per compounding period. So that when you go to your table along the top, you're going to find 4%. All right? And then you want to know how many compounding periods. Well, this is just for 1 year, so it's just going to be 2 compounding periods. So we find our factor, and the factor is 1.08160 times 4,000, and that equals $4,326.40. All right, to find the interest, we have to take the compounded amount and subtract the principal. So that should give us $326.40. Now we want to find the APY. That's the interest, the compounded interest, $326.40, and divide it by the principal, $4,000. That should give us 8.16%. So you can see that even though the nominal rate was 8%, what we really earned for the year was 8.16%. That's the annual percentage yield, and those are 2 different numbers. One is actually how much interest you earned in a year. That's the annual percentage yield. And the other is the rate they use to calculate your compounding interest during the year. So, if you would, please take a moment. I'm going to shut this off now, and go out and figure out this triad exercise. So Jill invested $7,000 in a certificate of deposit for 1 year at 6% interest, compounded quarterly. So 4 times a year. What is the compounding amount? What is the compound interest? And what is the annual percentage yield of Jill's investment? And it says round the APY to the nearest 100th of a percent. All right? So go ahead, try that, and when we come back, I will show you the answer.